Hello, this is my first refrigeration system that I have built. It considers a rotary compressor and heat exchanger and another heat exchanger which is frosting up. We have connected to the suction line, the low pressure line, with the red cable, but it's completely okay. And our pressure is in negative pressure because I'm using a blend of 30% propane and 70% butane. And the butane likes a negative pressures to be cold. And actually, this is my first system, and it looks like it does work. The compressor is really roasting, and it draws 2.2 amps from the wall, and that's about 460 watts. The condenser is really not that warm. This pipe right here is absolutely roasting, but after about here, around half of the condenser, it's about ambient. Now we can see that this coil right here is frosted pretty well. We are now seeing an ice melting on my refrigeration system. This is the evaporator coil and it's pretty frosted. There is some, I guess, about 3 mm thick ice on the copper line. Yeah, the compressor is, I guess, about 18 degrees Celsius. It's really darn hot. I can't touch it without my fingers burning. There was frost up to the liquid line or the suction accumulator, but it's only when I charged this system for the first time with this propane butane mix. At the first time it was only frosting for about this much, and I didn't add gas or anything else. I just powered it off for like 2 minutes and then restarted it, and then this happens. It was frosting all the way in here. I don't know why. That was pretty strange. That time as well, the working pressures went up, because at the first start it was under the zero, so there was a slightly vacuum on the suction line. So after the second start it was around 10 psi or something, but it was over zero. But yeah, there is some nice ice. So let's turn it on. You can see that is the suction pressure, and it's frosting up already. And now it's again frosting in here, and the frost is coming closer to the compressor. And that's pretty fast after startup. And as well, some parts of this capillary tube is frosting up too. That's pretty strange. And now the pressure is about 0. The high side pressure is, when I measured it, it was under 75 psi. Oh, the ice just cracked. Oh, that looks pretty nice. That's actually pretty nice looking. Oh well. So, the pressures are now when it's running. The low side pressure is slightly under vacuum. The high side is not connected because I don't have a second of these Schrader valve openers right now. But I'm getting it in around a week, so I can hook up the high pressure side as well on the same time. But what's when I disconnect the power when I can... This is the out of fuel. The low pressure side is rising, and because it's rising, the temperature is as well rising. This is actually how the was it heated vapor defrost in some dehumidifier works. It doesn't shut down the system, but it uses a solenoid valve to get the hot gas in the cold side, and then the high pressure gas melts the ice. It's actually pretty significantly faster than this, and there is pretty big chunks of ice. I actually haven't calculated that how much heat this thing is going to be able to move, and the capillary tube is just some strange amount that I had laying around from some old fridge that I took apart, and because I have some of the access to a place that has a pretty... I have access to a place that has some old fridge, and I was able to scrap some parts from there. The original capillary tube was this, and it's kind of short, and this is much longer, and I guess that it's pretty good, I would say, because low side pressure is slightly under vacuum in normal operation, and that's pretty good in my opinion, because I'm using a 70% butane and 30% propane, and the butane likes to be in lower pressure, because I might as well put a picture of the refrigerant from the refrigerant slider app. It's pretty handy, and it's made by Danfoss, so it's quality. And there is a small PC fan blowing air or sucking it from the condenser and blowing it on the compressor, because the compressor is really hot. It has been off for like 5 minutes or something, and it's really hot. Yeah, it does look like a bomb. And there's my vacuum pump. It's also from an old fridge. I measured the amount of this propane-butane mixture, and there is about 45 grams of the gas in this system. Before I added the gas, I vacuumed it down with this vacuum pump and let it vacuum it for like 15 minutes, and then it sat around 10 minutes, and actually before that I used this compressor to pressurize this whole thing to around, it was around 10 bars, so around 150 psi. Then this thing was here, and I was in that room with that cage, with these cages, because if this thing was to blow up, I wanted to be not there, because flying metal objects are actually pretty not that great. I was a bit curious about these solder joints, because these are just a soft solder of 90s, was it? Stupid thing, no. Yes, it is just some lead-free solder that I got from my local shop when I bought my new weller. And yeah, it has held up. All of these joints are made out of that solder, and there is no leaks and no explosions, so that's kind of good. I guess that there is something wrong with that compressor, because if there is some of you that knows, but without load and in vacuum it pulls the same amount as now, so 2.2 amps at 230 volts. I changed the original PO oil to just a regular mineral oil, because I can't get the refrigerator grade stuff. I need a license for it, and as we know, I don't have. Yeah, but it's just a first version. I'm planning on building a computer chiller out of this. Maybe not from this compressor, because it does pull really a lot of power and it makes some really bad noises. It makes about 3 times more noise than this compressor, and yeah, that's not very good when you are using it next to your computer and you want to watch a stream or something, or Netflix. That's not pretty pleasing to hear this compressor running, because it does make some loud noises. But yeah, see you next time.